This question is a great question. Basically, you're asked to investigate this function and see what is going on. And I'm looking for asymptotes. Now, you have to remember what your asymptotes are. So for a horizontal asymptote, we know by definition that you look at the value of the limit as it approaches infinity, or the value of the limit as it approaches negative infinity, because that is basically your end behavior. Having a little problem, there we go. So when we look at this function, for horizontal asymptotes, we always compare the degree of the numerator with the denominator. And we can see in this example here that the leading degree is a 2 in both the numerator and denominator, so it is the same. So that means the limit is going to be the coefficient, the ratio of the coefficients, which is 1 over 1. Now I ask myself if it's a positive infinity, so a positive number squared over a positive number squared is a positive value. So the limit will be 1 as I go to infinity. Now, will the limit be the same as I go to negative infinity? In other words, will my answer be 1 or will it be negative 1 as I go to negative infinity? And how you know is by trying a number that is a negative number into the original. So a negative number squared is positive over a negative number squared is positive. So again, the sign would be positive. So my answer also is positive 1. So I have a horizontal asymptote of 1 as the limit goes to positive or negative infinity. Okay, now let's check out vertical asymptotes. Now vertical asymptotes, we know by definition that as you approach a specific value c of a function, we are either going to get infinity, negative infinity, or it does not exist. That is the definition of a vertical asymptote. Or in other words, when you plug in the value c into the function, so you find the limit as a function approaches c of my function, I'm going to get a constant over 0. So the key idea here is that the denominator will equal 0. So let's go ahead and investigate this function a little more. So I'm going to need to open up a new page. Okay, and the original function was, in the numerator, we had x squared plus 5x plus 6 all over x squared plus 3x plus 2. So I notice this can be factored. And remember, we're looking at when will the denominator be equal to 0, because that is when we will have a vertical asymptote, if we have a constant over 0. I factor the denominator. Ooh, and I notice that one of the factors will reduce out. Now what does that mean? Well, that means when x is negative 2, we have a removable discontinuity. Removable. So in other words, we have a hole in the graph, or we might call that a point discontinuity, or a hole in the graph. But that actually wasn't the question. The question was, when do I have a vertical asymptote? Well, now I'm left with x plus 3 over x plus 1. So we said earlier, when the limit, as you put in a value, we get infinity, negative infinity, 0, or we get a constant over 0. So when will this denominator be equal to 0? Well, that would be equal to 0 when x is negative 1. So the limit as x approaches negative 1, we believe at that point would give us a vertical asymptote. Because if I were to plug in negative 1 into this function, I'd get 2 over 0. Great, so we just found where this graph has a vertical asymptote. So we could say at x equals negative 1, there is a vertical asymptote. Sorry, I'm running out of room down here, since the limit does not exist. Okay, since it is a vertical asymptote. Now I could check from the right and the left of negative 1 to see if it's positive infinity or negative infinity, but I have found my vertical asymptote.